Good afternoon. My name is Sean Gordon, and I'm the Principal Investigator for Project A7908, Spatial Decision Support for Open Knowledge Networking. Our core objective is to transform the way convergent organizations engage in collaborative decision-making. Our group was brought together under the Spatial Decision Support Consortium, an international network of professionals a number of us helped establish 5 years ago. Now, spatial decision support may not be a familiar term, but whether making choices about finding your way using Google Maps or making choices to address regional impacts of pandemics, we use maps and spatial information constantly to help us make decisions. And behind these digital maps are algorithms that are executing calculations and controlling how the results are displayed. In simple terms, that is spatial decision support, using maps and spatial data with algorithms to solve a particular problem. Many of our critical decisions as a society rely on geospatial data and analysis, including managing infrastructure, social services, emergency response, and natural resources. I think we all understand that these decisions benefit from integration across disciplines, sectors, organizations, and jurisdictions. What in this CXL program we've referred to as convergent problem solving. But the complexity of managing this level of coordination is daunting. Maps have long served as a bridging technology, which can help with this integration. But we believe that linking spatial decision support to open knowledge networking techniques and technologies can help transform how multi-stakeholder groups address convergent problems. Like most of the Track A projects, we're using knowledge graphs, which are effective tools for organizing and sharing large amounts of text information. However, they have little capacity for accessing the vast amount of geographic data available. The second open knowledge networking aspect we are integrating are collaboration tools and techniques to help people share information to solve complex problems. In phase 1, we tested these ideas with multi-stakeholder groups that are confronting water quality issues in the Puget Sound, wildfire management in California, and biodiversity conservation in the Oregon-Washington Cascades to Coast region. Each of these is a convergent problem at the intersection of human and environment relationships. And each of these problems occur in multiple regions across the nation. In each of these cases, we worked with and learned from existing organizations that are already doing convergent work across sectors, jurisdictions, and disciplines. For example, one of our collaborators was the Puget Sound Partnership, a network of over 700 organizations that are collectively addressing the problem of water quality. They've developed a hierarchy of goals and indicators called vital signs to guide their holistic problem solving. And it's something we can leverage in helping them organize their knowledge base and prioritize restoration actions. For each case study, we interviewed a cross-section of stakeholders from different sectors and different roles in the decision-making process, including scientists, analysts, managers, and even elected officials. Here are a few examples of the types of needs they expressed. And these are needs that they can't meet through Google or other existing technologies. We identified over 300 of these specific user needs from the 3 cases, and we organized these into 3 types of activities and built 3 prototypes to test how to meet these needs, including a knowledge explorer for browsing and querying knowledge graphs, a knowledge manager for organizing and contributing to knowledge graphs, and a knowledge workflow conductor that tests connecting spatial decision support to knowledge graph via microservices. In phase 2, we will continue to build on these tools, and we will add a spatial decision workbench, which adds collaboration technologies to our workflow conductor and leverages knowledge graphs to generate decision support applications at the scale of the problems that we face. In addition, we'll develop a collaborative web space creator that enables users to create collaboration spaces for diverse communities to come together, share information, and generate new knowledge connections. These tools are all supported and integrated through linked knowledge graphs. Our phase 2 team spans a diverse and interdisciplinary group of practitioners and researchers. We have 4 different technology groups, including one on geospatial ontology development, one on geospatial data integration, a group focusing on artificial intelligence and natural language processing for helping to automate knowledge graph production, and a software engineering team to tie these pieces together and design the web interfaces. Then we also have members who have been leading our work with each of the stakeholder groups. And finally, we have a new group dedicated to governance, education, and designing mechanisms for sustaining this effort over the long term. We have strong partnerships, expanding from 3 phase 1 regions to 6 phase 2 regions, each tackling their own set of human environment problems. The partners we selected are themselves convergent organizations, so they're not only applying our technologies, they're helping us refine what's needed for convergent problem solving and helping to co-create a variety of governance models, which will be critical to sustaining these efforts over the long term. Our collaborations already include connections with a number of federal agencies. These federal partners will provide us with access to their national networks to help establish other regional networks in other parts of the US. And we have team members and advisors from major non-governmental geospatial groups, including Esri Software, the Open Geospatial Consortium, a standards organization, and the University Consortium for Geographic Information Science. Our plans for sustaining and growing these networks over time builds on a framework of nested governance levels. And each level is aligned with its own evaluation metrics, such as participation within stakeholder groups, the number of interaction guidelines adopted by different groups, links between digital resource stores that are facilitated by protocols, and the number of digital knowledge products co-developed. In terms of deliverables, we have a phased approach to tool development, testing, and deployment that will gradually introduce different levels of capabilities to our partners. And in alternating quarters, we'll be soliciting user feedback and co-developing learning modules and frameworks for sustainable governance. In summary, our proposal is for use-inspired research that engages multi-sector stakeholder communities, implements interoperable knowledge graph networking tools and methods, and transforms collaborative spatial decision-making for solving complex convergent problems. Thank you for your time, and I look forward to your questions.